Good morning, everybody. How are you? I want to say a big special thanks to our presenter for Mr. C Live. That is the Dayton Metro Library and our friends at Think TV PBS. Thank you for making this possible each and every day. Today we are talking about amazing water, H2O. It has hydrogen, 2 hydrogen atoms, and 1 oxygen atom, and they're stuck together and they bond together to create a water molecule. So you might be saying to yourself, so H2O is water. What's H2O for? To drink, of course, to drink, right? And that's what we've got right here. I've got some H2O in this bottle. Now, what I also have here are a couple of grapes. I'm going to put one of these grapes into this bottle. Let's see what happens. Sinks. It sinks. These are just fun experiments that you can try at home, dropping grapes into water. Now, if you have a soda stream or carbonated water, I thought it'd be cool to try the same thing with that. It sinks. And it floats. And it sinks. So there's something really cool you can try, and the question is why is it floating? Why do they float? They float to the top. Look at this one, look at this one, look at this one. And then when it gets to the top, it starts to sink back down. And my question is why? We did density the other day. We talked about density. So those are things I want you to look at and try at home also. Oh, I've got a little baby grape. Let's see what it does. So all of these little bubbles in here, if you don't know, that's carbon dioxide. The soda stream takes carbon dioxide and squeezes it into the water. And that carbon dioxide, the little one, he got stuck between the other ones. You can't see it because they're stuck down here behind this. Look at that. It's so cool. Here, I'll turn you over here so they can see it, little guy. I wonder if other like fruit, what about raisins or like craisins or other things that you might have, and you can see, I think I'm starting to lose my fizz. Yep, I'm losing my fizz because every time I drop a grape in there, the carbon dioxide wants to grab onto it, and then it's like a flotation device. It lifts up the grape. And then what happens is the bubbles, when they reach the top, they pop, and the grape is more dense, so it sinks down and then hangs out on the bottom. And when there's not enough carbon dioxide grabbing that grape, boom, it gets stuck on the bottom. There's something I want you to try at home. What about raisin towers, craisin towers?
What if you have like just Sprite?
Ooh.
Would that change things because it's got other ingredients?
What if we try that with a soda? I want you guys to try that with a soda, and I want you to let us know how it works. So, Sprite has sugar in it and other things. Will the carbon dioxide help lift the grape in the Sprite? Give it a try. That's a good idea. All right, the next thing we're going to do is we're going to talk hot and cold. So I've got some warm water here. It's hard to see if water is warm, right? It looks the same as if it is cold. I wonder if there's something we could do to see the water behaving differently. Oh, I dropped an ice cube in there. It'll be okay. All right, so here we go. I've got my hot water and I got my cold water. I've got an idea. And to prove we have different temperatures, it's my thermometer. I think my thermometer might be messed up. I have a thermometer. Let's see. Yeah, this one, it's split. I didn't see that. All right, we're going to see what we have here. We're almost at 40 degrees Celsius. Celsius. That's a whole nother world. So a quick way, instead of doing the calculations, a quick way I like to figure out what temperature is in Celsius, is if you multiply it by 2 and add 32, that's roughly the temperature. So 36, 37, 38 times 2 is 76, plus 32 would be 98, right? If I did my math right. So that's 98 degrees. And then this one, I don't know if you can see it actually dropping. Can you see the thermometer dropping? This one is, oh yeah. It was ice water, so my goal, I'm hoping it gets down closer to 0 degrees Celsius, which is 32 degrees Fahrenheit. It's close, it's close, it's close. So this one looks like it's right at 7. 7 times 2 is 14, plus 32 would be 46. So we have a pretty good temperature difference here. But let's see if this helps us. I'm going to put a drop of food coloring in here. That's the hot water. And there's my cold water. And I want you to tell me, I want you to look at it, and I want you to see which one is spreading around faster. The cold water is sinking to the bottom. The red hot water is swishing it around. And you might be asking why? It's because those water molecules have more heat energy. And when something has more energy, it moves around faster, and they're bouncing into each other. And when they're bouncing into each other, they're taking that that food coloring drop, and they're smashing it into each other so that they can now move the color around more quickly than in the cold blue water. So it's not just, that's beautiful. Look at it just suspended there. So this is something I like to do with water, just to show you what's going on. I'm going to take this, I'm going to just stir it up with a paper clip that I have sitting here. And then I'm going to take another one, so it's not going to color my water. We're going to stir up. It's like a little tornado in there. Alright, we're going to try something now. I'm going to put this cold water, fill it all the way to the top. I'm going to bring this dish. Could you put that in the microwave really quick for 60 seconds? I want to get it as hot as we can. Well, not as hot as we can, but hotter than what it is. Oh, I need that back. Just for a second. I need to add a little bit of water. All right, I'm filling these up as close to the top as possible without spilling them over. That's good. Thank you. All right, now I'm going to put this in here. I'm going to put I'm going to put the red hot water, warmer water on the bottom. And I'm going to put the cold water, I'm going to turn it upside down onto this. We're going to see what happens. But if you remember, we did the surface tension experiment. We're going to put this on top. Oh, I hope this works. I'm going to turn it over. I'm dropping a little bit over here because alright, so we got, try to get them lined up, and now I'm going to try to pull this out. And before I do this, I want you to make a prediction what's going to happen. I'm going to turn this, we might have to use the other glasses. I have newer glasses. Okay, here we go. I'm going to turn this, I'm going to pull this over. Look at that. It mixed. The red water and the blue water mixed. That time we had, what was it, the blue was on top, and the warm was on the bottom. And now we have purple, right? So we can say that those two mixed, because when we mix red and blue, what do we get? We get purple. All right, so that's pretty cool. All right, now I'm going to move this over here just for a second. Out of the way. Bring another bowl. I'll take that. Is it warmer? Yeah.
Oh, yeah.
Oh, yeah. All right, so now we're going to take 2 more cups. Put this this water in there. All right, so this is our hot water again. Oh, it's steaming. So if you're working with warm water or hot water, please have a parent there. Parents, help your kiddos who are interested in doing this experiment. We want them to be safe, obviously, more than anything. So this ice water has been sitting a little bit longer. I wonder if it's a little bit colder. Come here, little ice cube. All right, get a little bit more water here. Oh, I got an ice cube in it. We'll get those out. Here we go. Let's get those ice cubes out without knocking all the water out. Perfect. Perfect.
The good news is it's just water.
It is just water. Here we go. Hot water. I'll try to drop them in at the same time. Here we go. Hot water, right? Yeah. And cold water. In 3, 2, 1. Whoa, look at it go. The red is spreading around way more rapidly. The blue is spreading around, but it's like...
Here, do you can pull these cards behind us?
I can put a card behind it.
So we can really see what's going on. Oh, yeah, that's...
Is that better?
Oh, yeah.
So we can see that the red is mixing it up. The blue is kind of just hanging out, right? Those molecules don't have as much energy. And now what we're going to try is we're going to try to put the warm water on top of the blue. So when we have the blue on top of the red, it turned purple. And when we put the red on the blue, it should mix together and be purple again, right? Okay.
We've got some different hypotheses.
Ooh, what do we got out there?
Well, someone suggested put the cold water on the bottom.
That's what we're doing. We're putting the cold water on the bottom this time.
I think they might have an idea.
Let's see what happens. I wonder what's going to happen. I hear predictions being typed on your computers. Get this red. All right, here we go. We're going to put this in here. Is it pretty full? It's pretty full. Going to top it off. Got another sheet of paper. Wish me luck. As I can get it over there without pouring. There we go. Oh, I think we're centered. It's hard to tell. I'm going to pull it with my right hand. I think we're centered.
Right. Lots of guesses that it's going to mix again.
Oh, I got a big bubble.
Turn purple. You want to hold the card behind again?
Yeah, I'll hold the card behind it.
Kind of to your right a little bit. There we go.
Hold on, I'll put 2 so we can see it from both angles. How's that?
That's perfect.
All right, so...
Say good luck.
Look at this. The red is sitting on top of the blue. Now, do we see purple? Yes, right here in the center. Where those two are touching. Those molecules are touching. And so the hotter water is giving heat energy to the cooler water where they're touching. And what's really interesting about this is that earlier when we tipped the when we tipped the blue onto the red, cold water just ran straight down. And that tells us something. It tells us that cold water is more dense. Those molecules are packed more closely together. And the more dense things, like when we did our density column, they sink to the bottom. And because these are less dense, they stay afloat. They're up here. And that's why this column looks different. Oh, it makes me nervous moving this. I'm feeling very brave. And that's why these two are different. This one instantly mixed.
I'm going to put the card behind the purple one too. That didn't make much difference.
And this one, no. And this one instantly mixed. And this one still is separated. Hot water, medium water where it's mixed, and then the cold water is on the bottom. That is a cool experiment that I have fun trying. That's why I love water. H20, baby. Whoop, whoop, whoop. What do we got?
Our friends Stephanie and Sarah asked, is that because heat rises?
Yeah, think about it. Hot things like flame, heat is less dense, right? So when you have a fire going, the flame goes up. And when you look at the air above the flame, you can see it's wavy, right? Because the hot molecules, the air molecules are moving up and we cause a convection current.
It's like when you went in a hot air balloon.
Oh yes, when I went in a hot air balloon. When they put the hot air inside of the balloon. God, that was so scary. When they put the hot air inside the balloon, the hot air becomes less dense inside the balloon and it lifts up that balloon and you can actually float around. All right, so what we're going to do is I'm going to slide these two over here out of the way carefully, right next to the computers.
Jonathan says you should drink it.
Drink it? I'm not going to drink this water, and I'll tell you why, Jonathan. One, it doesn't have ketchup in it. And two, these cups, I didn't clean them very well. Like, they didn't go through the dishwasher. They're like for my science kits. So I didn't wash these. All right. Oh, it's making me nervous over there. It'll be okay. Is it out of the camera shot?
I don't know.
Slow and steady wins the race. It's science time.
Moving cups.
All right. You guys ready for the next one? All right, I'm going to use this to wipe up a little bit of this leftover water. All right, here we go. I'll use this container. So, another fun water experiment. Get yourself a bottle, plastic bottle, glass bottle, doesn't matter. Pour some H2O into that bottle. Ooh, listen to the sound. Could you hear the pitch change? As the column of air is getting smaller, the pitch was getting higher. So now what we're going to do, something I love to do with water, just pour it out. Or, if you really want to get interesting, what I have here, same bottle, but on top, I have a little piece of mesh. All right, so this is like from our screen, from our windows. I didn't cut it out of a window for today's experiment. I had this. But what you do is you take this screen and you wrap it around. It can be the plastic or the metal wire screen. If it's the metal wire, be careful because they'll want to poke your fingers. And what we're going to do now is I'm going to pour some water into this. Actually, it'll make a little bit of a mess. Let's put it in here. Listen to that. The sound is just so cool. We have 60 seconds. I have a special activity we're going to try. It's based all on timing. Okay, I'm going to turn this over. What? Look at that. The water's not coming out. The water's not coming out. This mesh is doing something just to prove that there's still water in there. I've got a little toothpick. A little toothpick. Did you see it? Toothpick floated up in there. And the water still doesn't come out. So, defy gravity with surface tension. The water down here is connecting to those little holes, and it's not letting all the water run out. Look at that. That is awesome, right? Another cool experiment. Now, if I turn it sideways, it starts to run out. All right, turn that timer off for me. I'm going to be right back. We will come back to this one. This next one I have to do it with a timer. I have a 20-ounce bottle of water in the freezer. I'm going to bring that bottle out. Right now it's in liquid form. I'm going to pump it down onto the table, hit it like that. I'm going to strike it, and we're going to see what happens. I'll be right back. All right. I've got my water. I've had it in the freezer for an hour and a half. I'm just going to turn it. Oh my gosh, it worked. It worked. I've only been able to do it twice. Look at this. It's ice. Oh my gosh, it worked. It worked. I've only been able to do it twice. Look at this. It's ice. It's like it went from a liquid, and me striking it caused it to go to a solid. There's some liquid in there, but those water molecules, as they lose their heat energy, they start to slow down. And when they get connected a certain way, they form ice, right? And they were right at that perfect time where I was able to strike it down and do that. I want you guys to try this. I have another one. Should we try it again? I think that's a yes, right? Was that a yes? Of course it's a yes. Let's do it again. Get ready for it. Don't take your eyes off the camera. All right, here we go. You guys ready? In 3, 2, 1. That's so awesome. It never works for me. That is so awesome. Oh, now that one didn't work as well. That one didn't work as well. That's so awesome. It never works for me. That is so awesome. Oh, now that one didn't work as well. That one didn't work as well. So, I was laying them. They were in different parts of the freezer. This one was laying in the ice tray. This one was laying on chicken nuggets. So, we'll have to think about why that happened. But look, it's like slushy. Oh my gosh, this is going to be so good to drink here in a little bit. It's going to be just like frozen ice chunks. All right, that's cool. I want you guys to try this. 1.5 hours, 90 minutes in your freezer. When you put it in, put it somewhere where you can get it out very, very carefully. Ours is in a sliding door, so I had to be really careful so I didn't jostle it. Because if you jostle it and shake it, literally, oh, I wonder if it would work if we just flicked it like that next time. Just like, it's another video, for sure. All right, we're going to give that another whirl. I want you guys to try that. Another cool experiment. We've got water. We've got oil. And I've got food coloring. I'm going to use red, blue, and green. I'm not going to use the yellow because our vegetable oil is yellow. All right? So what I'm going to do is I'm going to take and drop a whole bunch of food coloring drops into this oil. Now, we've done density columns before, so I want you to start thinking about what may or may not happen. And do we have that in view? All right, here we go. Are we getting this, Mrs. C? So I'm putting a whole bunch of red drops.
You might want to come closer to the little side camera, or at least come forward.
How's that?
Keep coming.
I'm going to put some blue drops in. They're just little spheres. They're just beautiful. And they're all sinking to the bottom, right? And we've talked about that. Food coloring is water-based. What colors did I do? Did I do red already? Blue? All right, I'm confused now which I did. That's all right. We're going to add green. All right, so we got lots of food coloring in that oil. And they're separating, right? So what I'm going to do now, and I was really careful not to get any food coloring onto the sides of my cup. I say that, but then I splattered over here. So I'm going to pour on that side. I'm going to mix it up. And now it just looks like, it mixed up and turned black almost, right? All of those food coloring molecules are suspended in the oil. They don't want to mix. They don't like to mix. Here we go. I'm going to take this now. Do we have a good view?
I think so.
All right, I'm just going to pour it in.
Ooh.
All right, so it turned a little blue because I had a little blue on the side of my cup, and all of that oil went straight to the top, and our liquid, our food coloring, is suspended inside of that oil.
Do you want to put that paper back up?
I can. Here, I got a piece.
Oh yeah, that helps.
Now look at what we have going on. Isn't that beautiful and amazing? It's raining food coloring from the top of our oil. The food coloring is water-based. It's more dense than the oil. And what's happening is, as it's settling in the bottom of our oil layer, they're falling through. It's like a cloud. It's like little bitty raindrops. But they're just beautiful in color. Look at that. Mesmerizing, right? So we took that idea of our density column and we spruced it up a little bit with a little bit of colored rain. Everybody needs a rainbow every once in a while. Oh, that's just amazing. It's beautiful. And if you wanted to do a really, really cool, oh my gosh, we're going to do this later. Use ice water, right? Because you remember how the food coloring in the cold water didn't dissolve and mix in as quickly? Imagine this, that the food drop just comes down and you can just see the trail all the way until it hits the bottom. But that is, the blue's coming through now. It's just beautiful. And eventually, obviously, this water is going to mix all together. What do you guys think of that experiment? That's a fun H2O experiment. Oh my gosh. It just keeps raining color. We're going to have to get some really tight close-ups of this later and get some slow motion stuff.
Sarah was worried about why your finger is red.
Okay, my finger is red because of the food coloring. I didn't get cut or anything like that. But thank you for checking. It's just food coloring.
No
I've got blue and green too.
And we also have more requests for the ferret.
All right, we can get Pearl on at the end of the show. I put her in before. She was already running around for about 45 minutes to an hour before we came on air live, so she's rested. So when she comes on, she'll be sleepy for about 10 seconds. All right, so we're gonna let that. Oh, I just kicked my knee. We're gonna let that continue to fall, and as you can see, it's getting darker and darker because all of that food coloring is dropping in. I have one more experiment. Would you guys like to see it? Yeah, of course. All right, here we go. So I need one of my small glasses back that we use for, I crumpled that. I want to actually use it. So I'm going to have to dump one of these out into the sink really quickly. Give me 25 seconds.
Should we play a song?
No, we don't need to play a song. We'll be back in time.
You want to sing a song?
I can sing a song. It's science time. It's science time. It's science time. It's science time. It's so much fun. Learning fun for everyone. Everyone. All right, I'm back. Man, that tune was amazing. All right, so we've got our glass. Drying it out. We're going to move. Oh, just look at this. That's what happens when all the food coloring just mixes. It went from being transparent to being able to see through it to being opaque. I can't even see out the other side of it. All right. That corner is loaded with science experiments.
They were counting you down.
Was that close to 25 seconds?
They got to 7.
Oh, yeah. All right. So what I have here is a little teeny tiny plate of water. Not tons. And what we're going to try is I'm going to put a little candle in here. Just like that. And then I'm going to light the candle. And then what we're going to do is we're going to turn the cup upside down over the candle. So I want you to think about what's going to happen. I want you to think about what happens when you put an object, when you take away the air from a flame, right? So what happens there? So we know that a flame, and boys and girls, first and foremost, you should not be using flame at home. Don't play with fire. This is an experiment that only your parents should be doing. and you can be there to assist. We're going to light the candle. I'm going to move it to the center of the plate. We got it burning, and I'm just going to turn the cup upside down. So that flame needs and wants the oxygen in that cup to burn. And eventually it dies out. Can you see it? It's hard to see what's left on the plate because there's nothing left on the plate. It actually sucked all of the liquid into the cup. The flame was burning off the oxygen inside of there. It's reducing the pressure. And then we have our air pressure right here that's pushing this down, and it slides it into the cup and lifts it up. And then what's neat is, I wonder if I use that other pan, if they can see it better, Heather.
It's more about where the cameras are.
But the angles, yeah.
Yeah.
So hopefully you could see that. We'll try one more time. I'm going to light my candle. Happy birthday to me. Here we go. It's not my birthday. I just said that. We're going to put it on. Oh, that one went. It's already sucking the water in. So the candle's still burning. It's burning, it's burning, it's burning. And when the candle goes out, it's used up all of the oxygen it needs, or it can use in there. And now we have a pressure change, and it sucks it up. So that is another neat experiment that I love to do with water. So say hello to Pearl. Hi, Pearl. Hi, girl. Oh, she's shaking. Anytime she comes up in this space, she gets so excited because we don't let her run up here. But Pearl is 2 years old. A little over 2 years old. She was born February 2 years ago. And she is just an amazing little critter. She's so curious about everything. The thing I love about her the most is that, no, that's water. I know, that's water. The thing I love about her the most, look, can you see her shaking? She's just... They say that they shake when they get excited, and also when they are warming their bodies. But I think she's just pumped up to be up here. She's like, yo, little scientists of the world, thanks for tuning in to Mr. C every day. She also wants to say special thanks to our sponsors for the Mr. C live show, which is the Dayton Metro Library and our friends at Think TV PBS. Look at her. She's a little camera shy. Oh, no. That's actually a new cup, so that would be okay for her to drink from. But I've been pouring that water in and out. Yeah, what do you think? You want to do science later? What do you want to do? You want to do liquid nitrogen explosion? All right. You guys have been fantastic. Maybe we'll get our puppy on here. He needs a haircut. But after we get him a haircut, we'll put him on. His name is Puddles. Puddles and Pearl. You guys are awesome. Thanks for joining us. Thanks for coming in and being part of our learning family. We've got our little ferret. We call her little Ferrito. Pearl. And on that note, I've got to get her back downstairs because she's going to want to run around and it's not safe for her on this table right now. You guys have a wonderful day. We'll see you tomorrow. We're doing sugary, sweet, fun science. Oh, it's definitely going to be some sweet science tomorrow. Hope you tune in. And let us know what your favorite candy is. All right. Bye, guys. Have a great day.
Bye, girl.
Bye, Pearl. Burp, 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 burp.